This conference will now be recorded.
So you just feel it, this will be the first class. Okay. So see guys, from the statistics and the probability classes or sessions, what I would like to share it, you can able to see my course content. It can help you a lot. So what you need to learn, what you should, what I would like to explain it, I would like to show you over here. Okay. So first we need to go for understanding the statistic, and then we'll go for understanding the type of statistics, and then we can able to go for type of data, and then central measure of central tendency, and that we can do with help of the mean, median, mode, and when the data is grouped, then how we can do that. Next, is there any skewness is there in your data, and how we can do this, and measure of dispersion and coefficient of variation, standard deviation, variance for population as well as sample data, covariance and correlation. So I think we need to go for understand multicollinearity as well. So that is also one of the important thing. Multicollinearity. Okay, multicollinearity, and homoscedasticity and heteroscedasticity. Okay, those things we have it. So might if I miss it, I would like to share it over here. Yeah, so multicollinearity, what is hypothesis testing, one tail and two tail test, and the critical region type 1 and type 2 error, steps involved for hypothesis testing, and depends upon the p-value only we are choosing whether the null hypothesis or alternate hypothesis that we can see, and the confidence intervals, hypothesis testing for large sample size, comparing the two populations with a Jets test, and t-test and chi-square test and ANOVA test, confusion matrix, A/B testing, and we'll go for understanding random probability related things like random, what is random variable, discrete variables, and continuous random variables, and operationals of sets and operations on the test sets, probability density function, type of probability distribution, binomial distribution, normal distribution, empirical formula, standard normal distribution, probability density function and mass function, cumulative density function, examples of normal distribution, Bernoulli distribution, uniform distribution, and Poisson distribution, central limit theorem, and standard error. Okay, so actually there is few more concepts are there. Okay, definitely I would like to introduce those particular topics as well. Okay, if I miss it any statistic point, okay, I would like to add that particular thing into this particular course content. Okay, so I want to make it one of the standardized statistics and probability stuff, so that the people can easily get the job if you have really knowledge in statistics and probability. So that is the reason I would like to more focusing on the statistics and probability concepts. Actually, I miss it two or three concepts over here. Definitely, I can able to add it. Like um, so, their measure of dispersion is the right. Like here measure of central tendency dispersion, right? Here we can have something like IQ or like interquartile range outliers, those things we have it. That definitely I can able to introduce those particular topics actually. Okay, so see what I can do from this particular course content, I can able to mention it. If I finish any one of the thing, I can able to change the color into the green color. Okay, for this particular document I would like to modify this particular document. If I complete that particular topic for my explanation, I would like to be converting into, I would like to change the color into the green color. So if I miss anything, I would like to discuss even if I miss it any situation. Got it right? So my main intention is that I want to finish it this all the things in my conversations, if in my continuous sessions, if I miss anything, like if you see this particular thing, you can know that, right? If something is not in green color, then we need to discuss again. Okay. Yep. That's what, guys, I hope you understood. And let's start from the first onwards. Okay. If you really don't know about statistics, nothing worry. I would like to train you from the scratch onwards. Okay. Clear, right? Is it clear or not? So from this particular thing, we have some kind of assignments as well. Okay, like four assignments are there. These four assignments you should you should finish it actually. Okay, yeah. Let's start from the first onwards. Okay, like guys, yeah, I have created a document for you only. Okay, so if you have it any kind of issues, okay, if you have any kind of things, yes. That's right. Yes. So I created a document for each and everything because of that will be very important thing for interview. That is the reason I don't want to make it in the blind way of training. Okay. So I just want to share you the each and every point with the documents wise. So once my session has done, okay, even we can Google it or even you can go through this document. It's fair enough. I don't know, right, whether you're Googling or not, whether you're practicing yourself or not, I don't know, right? So that's the reason I want to share it, this particular document. And end of the day, I would like to, I mean, once if I completed statistics and probability, then I can able to share you that particular assignments. That assignments, you should finish it actually. Okay. Yeah. So that's the structure we should follow, guys. And now let's go for understanding the what is statistics. So try to understand my point. Statistic is a term, or else it's a science. It's a field of science actually. Okay. So statistics is nothing but it's a field of science, mainly which is dealing the gathering the data, okay, and reviewing the data, and whatever the data we have it, that particular data we can able to go for analyzing that particular data, and we can able to do some kind of draw the conclusions from this particular data itself. Okay, for example, let's take I have a data. This is the cricket players data. Okay, I have the cricket players data. Okay, so whatever the cricket players data we have it based upon. So see, I want to be first of all I should understand the problem statement. My problem statement is that which batsman is best batsman in ODs. Okay, so that is my problem statement. You understood my point? First, you should have the problem. So that particular problem we need to solve it. The problem is I want to find out the best batsman in the ODs. Okay, see, if you want to find out the best batsman in the ODs, we need to gather the data. Which data we need to gather? We need to gather the each and every batsman number of ODs he played, and what is the age of him, how many plays we did, how many centuries he did it, how many score, how many score we did it, and how many wickets he did we taken. So like so the data we need to gather it first of all. Okay, so statistics is nothing but mainly which was dealing the based upon your problem. We need to gather the data. Okay, whatever the data we have it, that we need to review it. Review in the sense whether that particular data is validated or not, that we need to review it. Okay, after that one, whatever the data we have it, cricket players data, that we need to analyze it. After that one, we need to draw the conclusions. Then that will be the procedure that we are calling it as statistics. I hope you understood, right? All statistics is nothing but which is dealing on the data itself. The data, the data, with the help of that particular data we are so first we need to gather the data, reviewing the data, analyzing the data, then we need to do some kind of conclusions. That conclusions will help you for decision making. Okay, So to do that particular thing with the specific tools behind it, we can derive many key observations and make predictions from the data in hand. You understood, right? We have some kind of statistical tools, something like Excel, SPSS, SAS, Python, or so then we can derive many kind of observations and we can do some kind of make the predictions from that particular data with your hands-on experience. Got it? So that's what the statistics. I hope you understood that particular point. In real world, we deal with many use cases. We use the statistics knowledge or unknowingly. Even knowing or unknowingly, we are using the statistics actually in different kind of scenarios in real time. You understood? Do you understand my point, guys? Knowingly or unknowingly, we are going to be using the statistics in real time. Okay, let's talk about some kind of examples. Let's talk about one such classic use of statistics in the most famous sports in India. As I think you guessed it right, that is the cricket, right? In India, most of the people are liking the cricket. Okay, so what makes Virat Kohli is the best batsman in ODIs, or Jasprit Buhara, right? The best bowler in the ODIs. See, what basis we are deciding that Kohli is the best batsman and Jasprit is the best bowler? How we decided that? We will have odd about cricketing terms like batting average, bowler's economy, strike rate, and we are seeing this kind of see. If you want to be understand this thing, first of all, you should know the cricket, right? That means you should have the domain knowledge. Okay, for example, I want to use this statistics in cricket gaming. Okay, cricket game, first of all you should have that knowledge on that particular cricket knowledge, in the sense you don't need to play actually. Okay, just the terminologies, what is the batting and what is bowling, you don't need to play, guys. Okay, if you want to apply the statistics on that particular thing, you don't need to play the cricket, but you should have the terminologies, you should have the domain knowledge. What is the batting, what is the bowling, and what is the average batting, what is the bowler's economy, strike rate, and whether he is the speed bowler or spinner. Okay, so at least we should have that knowledge on that particular domain. Okay, so once if we have the particular domain, if once if we have the knowledge on that particular domain, then what you can do, what we can do, okay, so we need to go for the, yeah, we need to go for the whatever the data we have it, that we can do some kind of statistics. Okay, like here on OD batting graph actually, so you can see this. So if you see the numbers in Excel, if you see the things, you can't take it decision, right? But we can see this is the batting things actually. So some people they played almost he was reaching to 150, sometimes he was reaching 120, sometimes he was reaching 100, sometimes it was more than 100, in between the 125. Okay, see, this is a graph. You can see how many score we did it on this particular year. Okay, like this is the graph also, we can see how many sixes we did it, how many fours we did it, how many ones we did it in this particular ground. Okay, see, this is the graph. I think even like when you are watching the cricket, okay, that moment in the middle of it you are getting some kind of visualizations, right? That visualizations actually we can do with help of either Power BI or Tableau, and so that kind of visualizations will help you to take the decision. So some people they're doing the betting on the cricket, right? Based upon that particular visualization only, they're predicting that next thing is that what will be happening. Okay, so that's what, guys. So we can see talk about statistics all the time, but very few of us know science behind it actually. Okay, so even without knowing of this statistics, we are taking some kind of decision, but actually internally the background is it's a statistics. Okay, here by using statistical methods, ICC compare the players, teams, and rank them. So if you learn the science behind it, we can create our own. Okay, so we can create our own rankings and compare the players terms, or better, if we debate with someone over who is better player. Okay, we can debate now with the facts and figures, because we will understand the statistics behind it. So we can understand above the graph is better actually. So the graph which will explain the so it was giving the more meaningful act. It was giving them more meaning on this particular thing. We will dive further into the various methods and terminologies which will help you answer the questions above as well. These are the vast use of statistics in much complex scenarios such as medical science, drug research, market, stock market, and economics, marketing. This all kind of area we are going to be applying the statistics. This is the complex scenarios actually. So not only in the cricketing, not only the cricket game. So actually the statistics will use in many complex scenarios. Might mean medical science, okay, drug research. For example, many people are implementing the vaccine for the many pharmaceutical companies are implementing the vaccine for COVID-19, right? So which vaccine is more better accuracy, which drug is working better than other drug. So we can compare the drugs for one particular issue, or one particular problem, okay, health issue, okay. And we can apply the statistics in stock market. Actually this is the sentimental stock market, guys. It was very toughest, it was very toughest thing to predict the stocks. That will be very complicated thing. Many people are failing, and they're losing their lives if you are investing the stock market without knowledge on the statistics. Okay, even you have the statistics, sometimes we are in fall down. Okay, and that's what economics, even if you want to do that marketing. So this kind of complex scenarios are there where we are applying the statistics actually. Got it, right? This is somewhat the importance of the statistics. And let's see types of statistics actually. So there is two main different statistics are there. The first one is descriptive statistics, second one is inferential statistics, guys. Okay, so descriptive statistics in the sense, for example, you have a data. Okay, you have a data that we can able to describe it actually. For example, whatever the data you have it, that we can able to describe, the description is Kohli is the playing very well from the last 10 years, and Bora is giving the very good bowling for the last 5 years. And that kind of description, that kind of summarization, we can able to give you with the descriptive statistics. Okay, you can read this particular point. This type of statistics deals with the numbers, okay, numerical facts, figures, and information to describe any phenomena. These numbers are descriptive statistics, or else report the industry production, or cricket batting average, government defects, movie rating. Okay, so this kind of description we can able to give you guys. For example, in the Friday, okay, one movie was released. Okay, and so in the okay, so one Friday the one movie is released. Okay, but evening only we are deciding that that movie is very good. This is the rating we are giving it. So how we are doing actually? We are taking some kind of information from the critics, and from the critics based upon that rating what they are giving, and we are giving that average rate for that particular movie. Okay, even government defects actually. So based upon the facts and figures only we are giving the decisions. You're not giving the decisions without knowledge. Okay, we are giving the decisions facts based upon the real what is happening in this particular situation, what will be happening in past. Based upon that particular two situations, we are describing this particular moment. Got it? That is descriptive statistics. For example, same example, and next 10 years, the in the ODs, Kohli is the best batsman. That is your prediction. That is your decision, right? How you did it? How you did it? Next 10 years, the COVID, the next 2 years, the COVID-19, we can't control it. That is the decision. That is decision we are giving, right? that is inference. Inferential statistics is nothing but is the decision or estimate, a prediction or generalization about the population based on sample. So if you have some particular sample data, so if you have some kind of sample data, based upon that particular sample data, we are going to be estimating the population. We are going to taking the decision on the population. We are going to predicting the population. We are going to be generalizing about the population actually. So this kind of things we can do on the data on with help of sample data. Okay, that we are calling it the inferential statistics. Guys, are you following my point?
Yes, sir.
Yeah.
Yes.
Yes. Yeah.
Yes.
Need need to need to are you following my point?
Yes, I am.
Yeah, can you please tell me what is descriptive statistics?
Where we are providing description of some data, as you explained, like movie rating,
Yeah.
like and so
So
on.
mainly we are giving some kind of description. It was something like it was reality only. It was somewhat numerical facts and figures. We are giving some kind of description, right? And based upon that numerical facts, figures, and information, we are taking some kind of decisions in future. We are taking some kind of estimations of your future. You're doing some kind of decision making in future about your population with help of some kind of sample data, that we are calling it say inferential statistics. Got it right? Yeah. So there we are getting two terms. One is the population, one is the sample. I think you guys are already aware of it. Population is nothing but it's a collection of all possible individual objects and measurements of interest. For example, if you want to do one particular experiments, and at this particular situation, we are taking the all possible things. We are collecting all possible things, that we are calling it a population. Sample is nothing but it was very simple thing. We are taking some kind of part, it's some portion or part from the particular population. Okay, so here the inferential statistics, it is also used to make inferences from the various descriptive statistics, simply describing what is going on your data. So here it was two things it was explaining actually. Inferential statistics, it can be used for makes the inferences from the data. But coming to the descriptive statistics, it was describing what's going on your data. Okay, makes the inferences, that is inferential statistics. Giving the description, that is descriptive statistics. That is the only two things you need to understand. Got it right? I hope you understood what is statistics and what are the types of statistics we have it. Mainly two types, descriptive and inferential statistics. And we need to understand the population and sample. Now let's have some kind of example over here. Let's take some example. This is very tricky example, guys. You can easily understand. Let's clear our understanding about the type of with the base of basic scenario actually. Suppose in our college there are 100 students are there. How many students are there? 100 students are there. You are interested finding out how many students prefer eating in the college canteen than college mess. See, in one of the college there is 1,000 students are there. See, you got a contract actually. For example, you got a contract to put the canteen in one college. Okay, you want to start the canteen business in one college. Okay, at this particular situation you can't go directly and start the canteen in that particular college, right? If you go it, then definitely your business can lose, or sometimes it will be good only. But before that one, we need to do some kind of business stats we need to apply, right? Okay, so my use case is, my problem statement is, I want to start the canteen business. I want to start the canteen business. At the particular situation, I went to the chairman and I'm talking with the chairman, how many students are there. Okay, he just explained it, there is 1,000 students are in my college, definitely you can start the business, you can start the canteen business in my college. That moment, you can't take the decision number of students in the college. You need to take the decision how many people are interested to take the food in the canteen rather than the mess. That is your knowledge. Okay, without knowledge on the business, if we have the 1,000 students in the college, okay, if we directly go for start the canteen, none of the people are coming for the canteen, then your business was lost. Okay, the capital amount was lost, and your monthly invest was lost. It was totally you're in the loss. Okay, that moment what you can take actually, you went for one statistician and a random group of 100 students you selected out of the 1,000 students. Okay, so it was very complicated to go for take the to go for take this information from each and every students, right? Okay, if it is the 1,000, might be it was 1 lakh, right? Okay, so that particular moment what you can do, we are taking some kind of random data. So it was 100. Okay, see here our population is 1,000 because of the total number of students in the college is 100. Out of the 100 we are taking only 100. This is the 100 is sample, and the sample size of 100, you surveyed the sample group and going for the result actually. Okay, so this is the 100 students, whatever 100 students data we collected. That 100 students are first year, there might be first year students are there, there are second year students are there are third year students are there are fourth year students also there. Okay, see, from the first year, okay, from the first year, 7 people they're interested for take the mess or to take the food in the canteen, they're visiting for canteen. 12 members are not interested and they are taking the mess in mess itself, college mess itself. Okay, now second year people, 13 people, we are taking the almost 13 plus 8 in the sense 21. 20 from the 21 people, 13 people are interested for canteen, 8 people are not interested in canteen, they are interested in mess only. And we are taking the 25 students from the third year student, and 20 people they interested for canteen, and 5 people are interested for mess. And coming to this particular this thing, and 30, so we are taking almost 35 people, 35 persons actually. Out of 35, 32 people are canteen and 3 people are like mess. Okay, you can see the total we are taking the 100. Out of the 100, 72 people are interested for canteen, 28 people are not interested for canteen. Okay, see, can you tell me, based upon your knowledge, whether you want to start that business, canteen business in your college or not? Will you start
Yes.
the canteen business in your college?
Yes.
Yes, you can start, but you can start. But thing is that there is some kind of statistics we can apply. Okay, here even you are doing the marketing, even you are not giving the discount on anything. This third year people and fourth year people, they are interested for only canteen, but the second year people and first year people, they're not interested for canteen. They are always they're going for only for this kind of mess only. Okay, that particular moment what I can do, I can give some kind of more discounts for the second year and third year people. There also count can be increases, right? If you give some kind of discounts for the second year and third year, might be the new joiners, for new join, this kind of marketing we can do for new joiners. It was 10% of discount, then we can the first year can't, the first year if you never go for mess, they're come for directly sitting in canteen and they're enjoying their food, right? Yes or no? See, if we have the data, then we can do some kind of research on that particular data. In marketing research, whatever it is, based upon your domain, we can do some kind of research on that particular data. We can do some kind of decisions on it. Let's visualize this particular data. Let's go for visualize the whatever the data we have it. Let's go for visualize. See, this is the blue color, it was canteen, and this red color is, it's a maroon color, red is, it's a mess, right? So this is the pie chart actually. This is one of visualization. And see, this is the bar graph. First year people, some people, see, this is overall, this is overall people visiting for canteen or mess. This is the years wise. This is the bar chart actually. Normally we are calling it say bar chart. Previous one, it's a pie chart. So this kind of statistics we are calling it the EDA, exploratory data analysis. Something we are visualizing and taking some kind of analysis that we are calling it's a EDA. Okay. See here, my first year people, this is visualization. For this particular visualization, I'm not, for example, the canteen who want to start, that is, he is not like educator. He is not an educator. Okay, so that problem statement is given to the one statistician. He was explaining some numerical things and numerical values. You could not understood, right? So that particular moment, what you can do, you just create some kind of interesting visualizations, and you should show them to your uneducated that investor. Okay, and then he can understand this graphs, right? See, Mr. XYZ, you can see the fourth year people, this is the overall this many people, this is the graph indicating that so more people are interested for canteen, very less people are interested in mess. But we can see years wise, fourth year people are very interested for canteen only, not for mess. Even third year also same thing. But second year people are moderated, but first year people are very poor. Then I'm giving some kind of decision to that particular uneducated person and that XYZ person. Yes, Mr. XYZ, you just go for giving some kind of discounts for the first year and second year. Then your business, it was profitable. Okay, this your business was little profitable. Okay, see that kind of things we can see. So 72% of the students are prefer for eating in the canteen. Out of the total students, we prefer canteen 44%, and from the fourth year, only from fourth year, 44% people are interested. Okay, overall 72, but only 44.4% is from the fourth year only. Okay, of the total students who prefer canteen, 72 from the third year and fourth year. See, out of the this thing, first year students are more inclined towards eating of the mess, right? So that's what the above statistics will give you as a trend of variation among the students with their preferences. We are using the numbers and figures to access the data. It will be the part of the descriptive statistics only. This is the part of the descriptive statistics. Now you suggest, suppose you got a contract to open the canteen in the college. Now with the above data, we can make some kind of assumptions, right? Third year and fourth students are main target of the sales restaurant. You can give the discounts for the first year students to increase the number of count. Since the most of the students prefer eating in the canteen, opening canteen can be profitable business. This kind of assumptions we can do, right? This is the business problems, guys. If we go for interviews, this kind of information only we should give you. Even it is a small project, we need to give the clarity of information. Okay, so you made the above inferences estimations for whole college based upon the sample data. This is the part of the inferential statistics who make the decisions on the descriptive stats on the sample data, guys. Okay, and see, though above the example very basic and real scenarios are much more complex, this would be help getting underlying the differences. We will see the more kind of examples in the rather next examples or next things. Actually, let's do some kind of questions over here. Okay, we can see some kind of questions here. The average salary of employee in the 2000 year is greater than the average salary of the teachers of the schools in 2017. Teachers at schools in 2017. So can you give me the answer? Above statistics is the inferential or statistics? Careful observe here. You just read this sentence and give whether it is the inferential or statistics, or inferential or descriptive. The average salary of employee in 2017 is greater than the average salary of the teachers at schools in 2017. Is it inferential or is it descriptive? Tell me. The above statement is example of descriptive or inferential. If it is the descriptive, then why? This time I want to take the person is Shahida was little of busy with her work and he was trying to attending the classes. I don't want to disturb her. And let's go for the Uppi. Mr. Uppi.
There is
Yeah,
inferential.
this
Okay,
is
go ahead.
descriptive.
This is the descriptive. Why?
Numbers, sir.
Which numbers?
2017 salaries, sir.
There is a 2017 salaries. It means that it's a descriptive? I just need some kind of a meaningful answer. Sahida, tell
Sir,
me.
it's inferential because we are looking for like average salary. That's why.
No. Inferential is all about taking decisions. You're not taking any decision here. You're not estimating any decision in future. So this is not an inferential. It's a descriptive. But why? How you can say that it's a descriptive statistics? Because of it was very simple thing, guys. It was giving some kind of summary information of two samples. Here we have that two samples, employee salary and teacher salary. Okay, you're comparing, you're giving description regarding about these two people. So basis on your average of employee salary in 2017, teacher salary or average salary of the teachers, we are comparing, we are giving some kind of description, we are giving some kind of summarization of that particular data. We are not taking any kind of decision. In 2019, in 2019 the teachers can get, the teachers can get, okay, this is assumption. Try to understand, is there any sentence over here? In 2017, in 2017, okay, the employee salary can get more than the teachers. Is there any sentence over here? We are giving a, we are giving it happen, already happened thing. We are giving the average salary of employee of the 2017 is greater than the average salary of the teachers at the school. We are not assuming, it's a reality. We are giving description. If you give that description, if you give a description in future, that is that is inferential statistics. Okay, so in 2022, in 2022, may employees can get the more salary than the teachers. That is the assumption, that is estimation, that is the inferential. This is not inferential, this is the descriptive statistics. Got it? You can see next example. By 2020, world will face the shortage of water. This is inferential because of we are assumption, we are doing assumptions, we are doing estimation. By 2030, by 2030, that means in future we are talking, world will face the shortage of water. We are facing some kind of issues in the water. That is inferential statistics. I hope you understood what is the inferential statistics and what is the descriptive statistics, right? Yes or no? In future we can talk about more examples. I hope at this moment I thought like you understood. Okay, I thought like you understood. Now let's go for understand the type of data. See guys, you can go for everywhere. Data can be two types. One is the categorical, one is the numerical. The data can be categorical data, the data can be numerical data, right? So categorical data in the sense it was very simple thing, it is a character data. Numerical data in the sense it was number data. Okay, see that thing, I think many people they know that. So categorical data representing the groups or categories like car brands, whether answer to the questions yes or no. Okay, that is the things we are calling it a categorical data. So numerical data in the sense, so we can able to give you the data in numbers. Numerical data represent the numbers. It is divided into two groups. One is the discrete, one is the continuous. Discrete in the sense it is some roundable value. Okay, so the whole number we are giving. Discrete data can be usually contains the finite numbers actually, and while continuous, infinite or impossible to count. For example, like I want to give you the height of the person. So whenever you can go for find the height of the person, actually people are saying that it's a 6 feet, but there is some change over there in the 6 feet as well. It's highly impossible to find out the exact height. Okay, and coming to this particular, how many number of years, that is also it's a fact only, right? Because of every moment it was changing, every moment your age it was changing. Normally we are giving that you might have the 28 years, but actually 28 years 6 months 4 days 3 minutes like we have it, right? There is a continuous that you can't be countable. That kind of things we are calling it a continuous. Okay, like temperature, discrete in the sense how many people are there in the class, that is finite number. How many people are there for this guy, how many kids are there, so what is the score in maths, that is the things, we are calling it a discrete. Okay, let's talk about the categorical data and the numerical data. So categorical data in the sense representing the characteristics such as the person gender, martial status, hometown, type of the movie they like. This comes to the characteristics. Okay, we are giving some kind of characteristics for something, that is a categorical data. Categorical data take some kind of numerical values. Sometimes if you see, sometimes categorical data you might have the 1 and 0 or 1 and 2, which means this is not a numbers, guys. We are representing that particular categorical data in the numerical format, but it is not the numerical data. Okay, so categorical data can take on numerical values, such as one indicating that, for example, sometimes one indicating that male, two indicating that female. Those numbers does not have the mathematical meaning, but it is not having mathematical meaning, but it's the numerical things only, right? There it is gender. Gender is nothing but it's a categorical data. For understanding, instead of writing the male and female for every time, they're writing some kind of numerical thing, something like 1 and 2. Okay, so there is no mathematical meaning at all. Don't confuse that. So if you see the gender, there is 1 and 2. Anjan, is it numerical data? No, it's not a numerical data. It is the numbers. It's not a numerical data, it's a numbers, which is indicating the categorical data. There is no meaning at all, any mathematical intuition. Okay, you could not add them together. Actually, don't add it. It was blunder mistake. It's a blunder mistake you never did in your life. Okay, now numerical data. So numerical data have meaning as measurements, like a person's height, weight, IQ, blood pressure, or they count such. Okay, such as the numbers of the stocks, shares a person who own. This kind of things we are calling it a numerical data. Actually, how many shares you want to buy it, how many shares you want to sell it, and what is your height, what is your weight, how many years, and what is your BP, and is there any sugar rate, and what is the percentage of your cancer. So that each and everything, it's numerical thing. The numerical data can be further broken into two types. One is the continuous and discrete. See guys, continuous, discrete in the sense it's a whole numbers, number of children in a schools, number of books in a library. Okay, you can see this kind of things, you can easily understood. There is some kind of finite data. That particular situation we are calling it's a discrete data. If the data is not a it's a continuous data. Sometimes the data can be continuous, right? Continuous in the sense represent their possible values cannot be countable. Okay, describe using intervals in the real numbers lines. Okay, for example, if you go with 8.41 or 8.414863, so there is various things are there, right? So that's what. Next one is level of measurement. See, previously I just explained it. There is two types of data will be there, categorical and numerical. Now we can able to measure of levels of measurements. Okay, this levels of measurements is nothing but it's a data. That categorical data we are calling it say qualitative data. Okay, see, this is the categorical data, this is the number data only, this is the levels of measurements. This qualitative data is nothing but categorical data. This categorical data, again there is two forms, one is the nominal and second one is the ratio. Okay, so nominal and ordinal, sorry, nominal and ordinal. Okay, this is the ordinal data, this is nominal data. Ordinal in the sense there is some kind of order. Okay, low, medium, high, average. Okay, that is order is the right. Nominal in the sense it is just person names or places. There is no meaning at all, there is no order at all, it is not following the order. That is nominal. So I can explain you that intervals as well as ratio as well. Let's go for understanding the qualitative. So qualitative is nothing but it's a numerical nominal data level of measurements. A nominal variable is one in which values serve only as a label, even if those values are numbers. Even sometimes the values in the numbers, there is no order at all. There is no order at all. For example, if we want to be categorize the male or female respondents, we can use the numbers of several one for the male and two for female, right? However, the values 1 and 2 in the case do not representing the meaningful order. See guys, for example, if you take the gender, if you write the male is 1, female is 2, then there is no meaning is male is first, there is no meaning for the female is first. Okay, so there is no meaning of order for the gender. Even there is some kind of numerical things, even if you represent the male is 1, female is 2, there is no meaning at all. In gender way, okay, gender way there is no order, there is which is not following the order, that we are calling it a nominal data. Okay, it's a meaningful order, it's not representing any meaningful order, carry any mathematical meaning, they're simply used as a label. Nominal data cannot be used to perform any kind of statistics computational. We have many statistical computations are there, so you cannot make it this all the things guys. So let's go for this level of measurement. We'll go with another file. Okay, see, you can see this is level of measurements we are talking about it. Okay, coming to this particular measure of representing, so because of such statistical do not have any meaningful nominal data. Say for example, any mathematical meaning, there are simply used labels. Nominal data cannot be perform any statistical computations such as mean, standard deviation. Such statistics do not have any meaning when used the nominal variable. Okay, however, nominal variables can be used to do not use it to cross tabulation. Cross tabulation in the sense we can able to show the data in the tabular format, like how many number of males are there, how many number of females are there. Okay, how many people are visited. Okay, there is some kind of, we can able to show the data in the tabular format. That tabular format we are calling it say cross tabulation. So this is the nominal data. We can able to apply only chi-square test. Only chi-square. This is one statistical test only. This is the chi-square test can performed on your cross tabulation of nominal data. Only if the data is nominal data, we can apply only one test, that is chi-square test. Okay, that is, please remember that point. What is chi-square and where to use it and how to use it, definitely I can explain you, don't worry about it. Okay, I can explain clearly each and every point. Okay, I just need your time, that's it. Okay, definitely I can able to spend for a lot, and I would like to share it whole information. Okay, don't judge for one day. So chi-square test can performed as a cross tabulation of nominal data. Okay, see, however, we thought we quote different categories, right? We cannot say that since 2 is more than 1, there is a meaning at all, right? If the gender, there is no meaning of male is greater than female is greater than male, there is no meaning at all, male is greater than female, there is no thing, so we can't do that kind of things. So let's go with ordinal data measurements. So ordinal in the sense there is some order. Okay, values of ordinal have some meaningful order then. For example, education level, like first 10th class, higher education, schools level, high school level, graduate level, postgraduate level, and PhD level. Okay, there is some kind of order is the right. Yes or no? Who is best? We can compare it. For example, we can try to understand. There is two persons are there. There is two persons are there, and one person is the PhD candidate. One person is the master PhD candidate. So can you say that which is the best knowledge person? You can easily compare it. You can easily compare it. Okay. So because of ordinal in the sense there is some order. So the comparison can do. So you can see, for example, education levels would be the ordinal things actually. There is definitive order to the categories, like graduate is higher than the undergraduate and undergraduate is higher than the school level, right? But we cannot make any kind of arithmetic operation. We cannot add the graduate and undergrad, something we can't, you can't perform it. Even you can mention, even you can able to representing that particular categorical data as a numerical thing, but don't do any kind of mathematical operation. Okay, don't make it any kind of mathematical arithmetic assumptions behind that. We cannot make any other arithmetic assumptions behind that. Okay, only we can do the comparison. For instance, we can assume that the difference in education level between the undergraduate and I level is the same as the difference between the graduate and undergraduate. Okay, so we can use the frequencies, percentages, and certain non-parametric statistics with ordinal data. However, mean, standard deviation, and parametric tests are generally not appropriated to use the ordinal data. Again, we cannot perform the mean, standard deviation, and this kind of parametric statistical test. You cannot apply it. Okay, you cannot apply it. So we can use the frequencies, percentages, and certain non-parametric statistics. For example, frequencies, how many number of times one particular thing is repeated, that is frequency. How much of percentage which was having in this particular whole thing, that is also is one of the non-parametric statistic. Okay, parametric statistics are mean, median, standard deviation. Those are the parametric statistical tests. Non-parametric test in the sense frequencies, percentages comes under to the non-parametric tests. Okay, let's see. This is the category and this is the code. Upper class is nothing but 1, middle class is 2, lower class is 3. So there is some order or not. So category with a highly satisfied is 5, satisfied is 4. For example, you want to give the feedback. Very bad is 1, below average is 2, average is 3, satisfied is 4, highly satisfied is 5. Okay, you cannot perform the mean of it. You cannot perform the mean of it. That is again blunder mistake, because if it's a categorical data, you can't apply. It is a qualitative data, you can't apply any kind of parametric test. Okay, if it is ordinal data, we can apply some kind of frequencies on the particular things. Okay, in the above example for ordinal data, the data is given sense of comparability, so we can do the comparison. So that is, we can say that the second table highly satisfied better than the average, though we can say that the difference between the highly satisfied is same as the below average and the very bad. Okay, this kind of things we can say that, guys. That's for this particular measure of ordinal data. Now quantitative data, levels, interval scales, data levels of measurements. Okay, see, intervals label in the variable in the sense we can do some kind of make arithmetic assumptions, and degree of difference between the values. An example of interval variable could be temperature. Can correctly assume that difference between the 70 and 80 degrees in the same as the difference between the 80 and 90, right? So however, the mathematical operations and multiplications and division do not apply. Even it is the interval data, even it is the qualitative data, sometimes we cannot apply some kind of multiplications and division, guys. We can do only addition and subtraction only things. Okay, because of it is the interval data, we cannot apply the multiplication and division. For instance, we can accurately say that 100 degrees is twice has to 50 degrees. Additionally, interval variables often do not have the meaningful 0 point. For example, temperature of 0 degrees in Celsius Fahrenheit does not mean that complete sense of heat. Okay, So interval variables can be used to compute the commonly used statistical measurements, something like average, standard deviation. Many other advanced statistics tests and techniques also require intervals or ratio data. Okay, so this kind of things we can do. Measure of time of historical event comes under to the interval. So we can able to go for measuring the time in historical event, that is comes under interval scale. Since years has no fixed origin, 0 years is different for the different religions and the countries, right? In the meanwhile, so ratio scale data level of measurements, so we can go with some kind of ratio things. All arithmetic operations are possible: addition, subtraction, multiplication, this kind of things we can apply on the ratio data. Okay, we can accurately say that 20 pounds is twice highly 100 points, right? Previously can't say that. Additionally, ratio variable have the meaningful 0 point. There is 0 point, exactly 0 points, meaning object no weights at all. Other examples of ratio interval include the gross scale of the company, exponential of the company, the income of the company. This is the things will comes to the ratio. Ratio is the exact number actually. Okay, we can do some kind of statistical test. We can apply on these particular nominal data. Nominal data we can apply only mode. Okay, and nominal data we can apply only mode in the sense frequency, only frequency we can apply. Ordinal data we can apply the sequence of variables, mode and median also we can apply. Okay, and the ordinal in the sense there is some order, right? So median value we can definitely apply. And interval in the sense other than the multiplication, division, absolute zero, any statistics we can apply. Okay, coming to the ratio, we can apply all kind of statistics we can able to go for apply actually. Okay, see guys, this is for today's lecture, and tomorrow's lecture we can start with this particular measure of central tendency. Okay, this particular things I can able to explain it. See guys, please read this particular document. I hope you can understood, because of this is little bit of theory, and so I don't need to miss it single point as well. That is the reason I'm using this particular document. I hope you can understood my point. So please read it after the session has done. Okay, then tomorrow's session I would like to go for starting the central tendency. See guys, I would like to go with I want to make it this what are the things I completed as of now. So I want to make it this as green color. Okay, so tomorrow we can able to talk about measure of central tendency, mean, median, mode, grouped mean, skewness, effectiveness and use of central tendency, measure of dispersion, and so this one after one we'll talk about it actually. Okay, see guys, not even in practical we can apply this thing in tools as well, like SPSS, Python and R as well we can apply on it. Okay,
Can I get access to this folder? Yeah, I didn't know.
I would like to show you, I would like to share with you, and you just drop the mails in my WhatsApp. Okay,
Yeah.
I would like to give you the all access. Bye guys, thank you, take care.
Thank you, sir.